Good Tuesday to you again, Gov 603, and welcome again to week 7 and our review of week 6. Boom! More soothing mint tea. Good stuff. I think is okay. So for this video, we're going to take a look at the questions and your answers from last week. See if we can't fill anything in, make them more understandable. That is the questions and the concepts that you're being asked to get your head around by way of reading some of your answers. Okay, so last week we were concerned with external validity and validity in general of a study. You know, I want you to develop into critics. I want you to be critical. I should say, I don't want you to be critics. I want you to be critical, not cynical. When you see a study thrown up, especially in politics, I want you to be skeptical. The first thing I want you to start asking is questions that pertain to sampling, meaning how many people were asked this question or these questions in this polls? What was the demographic? Where do they live? What are their political affiliations? And if those things aren't known, and if they're not presented to you, and a lot of times when you get things through the news, they're not, but you get it, you got to dig into it. If they're not present, then ping, that's the red flag that someone is up to something, that they're using numbers to promote a position rather than to promote, an opinion. So be on your guard. Okay, let's take a look at the questions. Question number 1, what are some of the ways to improve external validity? And this begs the question of what is external validity? Describe how you would improve external validity in your proposed research. Okay. Karina, you write external validity, et cetera, et cetera. You give us a nice way. You give us a nice definition of that. Some ways to improve external validity can be random sampling, random assignment, population specification, or meta-analysis. One way I plan to improve the external validity of my research design is to perform random sampling for participants in my survey so that I may get a broader opinion on the topic at hand. Okay, and why is this important? Well, let's say that especially where politics are concerned, there's always, and this is true for most things, but in particular things like politics, there's always charged opinions. People tend to be grounded in their opinion, driven by cultural, ethnic, sociological, familial factors, and not analysis of the policy or the political person. Okay, we're not pointing any fingers. We're just saying that's how the political beast behaves. So let's just say, for instance, and I'm not picking on anybody, but let's say you wanted to conduct some research into whether the public thought that there should be a process of impeachment initiated in the House. That's where impeachment initiates against the current President Joe Biden. Right? And you want to just you can't ask everybody in the country because you don't have time and it's hard to get to them. But in statistics, you don't have to. If you ask a statistically significant sampling, and for the entirety of a country, that would our country about 300 million. That would be like 3,000 people. If you could get 3,000 people to give you answers to your survey, you could statistically infer that the trends that emerge in your study group, your sample, 3,000, are likely the trends that are national. Only, and that would be your external validity, only if your sample is sufficiently random as to represent the randomness of anybody on the street. Because if you ask people who are all, they identify politically as Democrats, that's going to tilt your answer, and that may not be representative of a country as a whole. If you ask people that say, well, I'm Republican, and you ask them only, or even if you ask them in a lopsided percentage, say 70 Republican, 30 Democrat, or 30 Democrat to 70 Democrat to 30 Republican, that's going to tilt your answer, and it won't be externally valid. Okay, so that's why it is That's why it's important by way of your research design. In this case, a Karina random sampling. Good answer. Okay, question numero dos, number 2. Briefly explain how proper use of the sample, the sampling frame, and the study population, the theoretical population, can help minimize research bias. Okay, Patrina, let's take a look at your answer here. Proper use of samples refers to selecting diverse and representative group for the target population. So if the target population is the whole country, got to have a sample that reflects that. Okay, this guarantees results are applicable outside the research sample. Okay, stop right there. No, it does not guarantee. It means that you can make the statement it is statistically significant. Be careful of that as a researcher and reading research. When you are extrapolating, that is, you take the conclusions from something that you can see, your sample, to things that you can't see, the rest of the demographic, wherever there are, nothing is certain. It's just probable or improbable or high probability, mid probability, low probability, these sorts of things. Okay, and we're not picking on you, Patrina, but that when you say that, you got to be careful. Okay, a random sample strategy gives all population members an equal opportunity of being studied, decreasing bias. Yeah, because maybe, back to the analogy of should there be impeachment proceedings initiated in the House of Representatives against the current president? Well, according to whom? The people that voted for him, probably not. The people that want to see him defeated in the next election, probably so. Okay. Study populations are qualified participants who satisfy specific requirements. This demographic must be properly defined to avoid prejudice from omitting groups or including individuals that don't fulfill standards. Now, that's right. Now, I want to make sure, and I want you to make sure that you understand what that means. All right. So, for instance, if you're studying the effects of smoking on, respiratory health, okay, you should probably have some smokers in your study, because the who ought to be in there is driven by the what you're trying to research. So you as a researcher, you're deciding that. And those two need to align. And again, as a reader of research, look for that. And if they don't align, then you go, I'll give you an example. I've worked in the not-for-profit sector for many years, and one of the big questions that's always out there that not-for-profit organizations are trying to figure out is who gives the most money and why do they give? And most of the studies that ask that question have been done at universities with college students, and they're often, the college students are paid to participate. This is more common than you know. And they will show them images generated by not-for-profits and say, look at this, would you give this organization money? Look at this, would you give this organization money? And then from that, they conclude these sorts of images used are most likely to trigger people to give money. Okay, fantastic. But I started looking at that and I thought, I think there's a bias selection. And bias doesn't mean that the researcher is doing something wrong or up to try to play a trick on you. It just means that the sample population in there is in itself tilting the answer. Because I said, I've been working in the not-for-profit business for a long time, and college students are not near the top of the list of the people that give money. So why are you asking them? It's not like they're not good people. They just don't make up the core of the demographic of people who give money to not-for-profits. So what is that core? Well, it's about 45 to 70 something. 65 is really the top. It's that demographic. So I said, okay, let's take a look at that group. And then instead of paying them, let's ask them, minus the financial incentive, looking at certain materials, would they give to the organization? So I conducted a study in which, and then gender. Which gender is most likely to give? So I conducted a study, and it's women, by the way, focusing on the gender within the specific demographic without financial incentive And what do you know? The sorts of images used that elicited the most donations were the complete opposite of those that were favored by college students. All right, so this is why it's important. It's not because necessarily the researcher is up to something sneaky. You just have to be careful about how you design your study. Okay, anyway, back to you, Patrina. Finally, theoretical populations include all prospective participants in a study sample who were excluded owing to their time or resource restrictions. By considering this wider theoretical population, researchers can uncover bias in their samples, because sometimes bias will just creep in. It doesn't get designed in, it just gets in there. Sometimes people don't want to answer your survey. They don't have time. They don't like surveys. I've done a lot of research on distressed populations, like refugee populations, who happen to get surveyed frequently, because every aid organization on the planet, excuse me, that's there during a disaster wants to know, are we making a difference? Okay. So I was working in Haiti after the devastating earthquake of 2010. I was conducting some research, hand out a survey, and you just see the eye rolling. It's like, oh, good Lord, not another survey. We just filled out one of these 10 minutes ago. And from a participant's perspective, not only were they survey exhausted, they had to keep wondering. You're asking me all these questions, but then I don't see relief in the way of aid that you bring in proportion to the questions you're asking me. You're asking me, is this relief effective? And I say no. And then the same stuff shows up. Well, because there's a long bureaucratic process between getting the answers from a survey and then adjusting the aid that's going out to a distressed population. Distressed population may not know that. They may not give a darn. So they don't take the survey. That injects bias into your results, even though you didn't design it that way. You didn't go, oh, let me see if I can put some bias in here. Okay. Question number 3, explain the following two terms, sampling distribution and sampling error. How are they related to the 68, 95, and 99% rule? All right, this is one that I need you to pay attention to. Jacob, sampling distribution is the distribution of a statistic if an infinite number of samples of the same size were taken for the same population. Each sample would have the slight variation due to the nature of the data collection, but they would all have similar results since they came from the same population. All right, and that's exactly right, Jacob. Well, let's translate that into straightforward English. So imagine you had all the time in the world and you wanted to know if people thought that it was really one person, one vote would make the difference. Okay, because believe it or not, there's some skepticism about that proposition, and you could go out and interview as many people as many groups. So let's say 500 at a time. All right. What you'd be looking for is the curve, the distribution of the curve. Each of those, if you were getting, if you didn't have errors and bias in there, each of those curves should look relatively the same. I mean, if you superimpose them all on one another, say put them on clear pieces of plastic. And what I mean by curve is how many people said yes. You set up a scale of 1 to 5. Do you agree with the following? Respond to the following statement. One person, one vote makes all the difference in a country's future. Strongly disagree would be number 1. Disagree, number 2. Number 3 is I have no idea. Number 4, agree. Number 5, strongly agree. And then you ask 500 people, and then you ask 500 more, and 500 more, and 500 more, and you get this distribution. You get this curve in which, let's just assume that the top of the curve is where the 3.4 to, I got no idea, to, yeah, maybe I agree. All right. If you did that over and over and over and over, you're looking for a similar bell curve each and every time. This tells you that you have an accurate sample distribution. All right. Okay. The sample distribution represents the average results of all the samples collected and their minor fluctuations. Okay. So maybe like one of those 500 You happen to ask, people that were really economically depressed and didn't see that there was any connection between how they voted and what happened in their lives. Like, oh, hell no. All right. And then that give you a whole bunch of ones. All right. So there's a little bit of fluctuation there. Sampling error represents the range of variability in a sample distribution and shows how precise a statistic is. The greater the sample size, the smaller the error because it closely represents true population. On the other hand, the smaller the sample size, the greater the error. Now, Jacob, that's right, but I want everybody to pay attention to this. The potential for the greater or lesser of the error. Okay, now to the all-important 68, 95, and 95% rule indicates confidence in the sample results. The sample error forms the foundation of the 68, 95, 90% confidence intervals. Those intervals demonstrate across the sampling distribution. Okay, let's translate that into English. Something really interesting about statistics, because most people think, statistics, math, and math is true, and math is science, and it's not faith. And hold it up, because the very foundation of statistics is actually the very foundation of our faith. And I'll explain. Okay, well, but first I need a little more tea. This cough, what's going on? This book, these glasses, this hat, these are all organized objects. Okay, they have a specific shape. And, this hat's not the same as these glasses. They're organized in a very different way. Now, who organized the shape of this hat? I have no idea. But what I do know is there was an organizer who designed the shape of this hat, or say even the Regent logo on this hat. I have no idea. But what I do know is that there was a designer. Nothing that is organized or designed does not have an organizer or designer. That is the foundation of our Christian faith. Now, in the statistical world, it is assumed that material reality has such a consistent organization that things happen consistently in repetition, predictably in repetition. It's so well organized by the organizer that it's boringly repetitious. So, for example, I can say with a high degree of certainty that there is a zero probability that right there behind me on the floor of my study, I still have to determine whether it's going to be carpet or no carpet, that suddenly a bunny rabbit is going to appear, hop around in a circle, and then just as spontaneously disappear. That's not going to happen. Things do not just suddenly come into being and come out of being in a randomized fashion. So statistics assumes that there is such an ordered nature to material reality that things will happen in a predictable way. Always. So for example, if you took a coin, just like this quarter I've got here in my hand, and let's say you and a friend, you wanted to test the probability of this order. What percentage of which are we certain that the things always happen in a predictable way? And you flip the coin 10 times 10. So you flipped it 10 sets of 10, so 100 flips. And each time you flipped it, you called out, let's say your friend flipped it. Okay. Your friend flips the coin, whacks it on his or her hand. And then, you're not seeing, but then your friend calls out heads or tails and you write it down. Heads, tails, heads, tails, heads, tails, heads, tails. You could assume that reality, material existence, is so consistently ordered that 95% of the time it would be equally distributed between heads and tails. So if you flipped it 10 times and then in 10 sets, the average of all of those 10 times 10, 95% of the time, it would be an equal number of heads and tails. But what if it wasn't? What if over the 10 times 10 flips, the 10 sets of 10, it was 70% heads and 30% tails? Aha! As a researcher, you would automatically assume that there's some other force besides the ordered force of material existence that governs everything that was acting on that coin. What other force, you might ask? Ooh, I don't know. Maybe it's a trick coin. Maybe it's heavier on one side than the other, and it's designed to show more heads than tails. That could be a force. Maybe your friend, just for kicks, is lying to you. And part of the time that she sees tails, she actually sees heads. That would be a force acting on your experiment. All right. In standard statistical research, it is assumed that if something happens 95% of the time in the ordered way that you would expect, there's no external force, there's no phenomenon disrupting that. That 5% that's left over, if it's 5% or greater, if things deviate from the norm 5% or more, because then 95% starts to get smaller, that's called the confidence interval. Okay, does everybody understand that? Now, in some areas, in some research, that confidence interval is even. Did I say confidence interval the first time? I think so. Is even tighter. Pharmaceuticals, for instance, when they test a new pharmaceutical, they have a very, very, very low tolerance for something else happening besides what they intend to happen when they give someone the medication, unless you're making COVID vaccines and then you get special permission from the government, shielding from the government for any legal liability for anything that happens to anybody. And I'm not making that up. I'm not knocking, I'm not an anti-vaxxer, but this is true. You get special legal protection from any harm that your product does because you haven't tested it to determine. And most medicines have a confidence interval of 99%. That is 99% of the time, exactly what you design this thing to do has to be done, and not, like a third nipple or an eye in the middle of the forehead, or the person's hair falls out, or something else is completely outside of what the medication is designed to do. So for normal operation of reality, the assumption is it's just going to do it, does what you observe it does 95% of the time. And if it's any less, there's some other force acting on it. That's what we mean by confidence interval. And if you don't understand that still, please send me an email, because it's really, really important that you do. Okay, question number 4. Explain the following two terms: stratified random sampling and random sampling. How are the two practices related? Joshua, and you just like bam, right to the jugular here. Stratified random sampling is a method that divides the group population, typically based on certain characteristics, like gender, age, political affiliation, whatever you like, into small, homogeneous or homogeneous, whatever you like, potato groups, or strata. Think of like stratification. Okay, that do not overlap, so that a simple random sample is conducted in each individual group. Okay, random sampling is essentially selecting X number of cases out of the overall number of cases in the sampling of frames, so that the aggregate number of combined cases is equal in probability of being selected. Okay, now let's turn that into a little more straightforward. So, and why would you do this as a researcher? Well, let's say you're again, back to use this analogy before, you want to take a look at how do the hours that you keep open a voting station affect voter turnout. And let's say people are like, these things are all staffed by volunteers, and hey man, they want to go home at 7 o'clock. So we're going to close down the polls at 7 o'clock. Boom, done. Okay. But you go, I think there's certain segments of society, like what about people that work second shifts, and they're working evening shifts and they can't get out, or they're working 12-hour days and they can't get out to go vote. You close these things at 7 o'clock, and they're not finished until right at 7. They're working from 7 a to 7 p. And by the time they finish with work and they get out and they get to the voting place, too bad for you. So you take a sample, and then you start to pull out chunks of pieces of that sample. So let's say people that work 12-hour shifts. Let's say the elderly. Let's say people who are young, like say below the age of 18. And they don't even get out of bed till like 5 in the afternoon, the evening or something. I'm making that up. Okay. And then you want to look at how each of those groups, how each of their voting patterns behave when the poll is closed at 7 o'clock. Is there any dramatic decrease in voter participation for people that work 7 in the morning till 7 at night when polls close at 7? Because you're conducting a study that looks at, well, if we kept the polls open longer, would that increase voter participation? All right. So in doing that, you're stratifying the sample. Okay. Now, random sampling means you just pick a certain number from all groups and run the test again. Okay. Good answer, Joshua. All right, everybody. If you don't understand any of these concepts, first, please put in the time to get your head around them. But if you're still not, and it's still like, I'm not quite sure what we mean by external validity or confidence interval, what do you mean? Send me an email. We will get you straightened out. I promise. Okay. Everybody have a great rest of the week. Thinking about you, praying for you, and I will see you, as always, on Canvas. Bye-bye.